Yes, good morning all of you. Today we will see remaining preparation methods of alkyl halides. In previous class we did preparation of alkyl halide from alcohol, alcohol treated with phosphorus halides. Second one is Konnurs reaction. Konnurs reaction is alcohols treated with locus reagent, you are getting alkyl halide. One more named reaction is Dorchen's reaction. Alcohol will be treated with trinyl chloride. In presence of pyridine, you are getting alkyl chlorides, sulfur dioxide, and HCl is the most convenient method because the side products of gases themselves they are going in atmosphere. So what is the action of pyridine over there? The pyridine is acting as a base. That's why if any unfortunate or if any traces amount of HCl is in the mixture that can be taken by pyridine, then we are getting purely alkyl halides. Now we are getting the fourth method for the preparation of alkyl halide. It is nothing but from halogenation. Halogenation. Yes, I think you know what is the meaning of halogenation. Introducing of halogen. Yes or no? So introducing of halogens. Nothing but X में fluorine, chlorine, bromine, iodine. So through addition or through substitution, anyway we are introducing the halogen into the given particle. So first of all, I will give the one concept to you. Whenever alkanes is involving in the reaction with halogens in presence of sunlight or H nu. Sunlight means nothing but energy means nothing but H nu. Then we are getting which compounds? Alkyl halides we are getting. Already you learned this one in first year organic chemistry under hydrocarbons. Chemical properties of alkanes is the first chemical property this is. Whenever alkanes will be involving in the reaction with halogens in presence of sunlight, we are getting alkyl halides. Did you remember? It is going through free radical mechanism. Free radical mechanism. Yes, I will give once again the concept for you. Free radical mechanism. What is the meaning of free radical mechanism? Just you have a one chemical A connected with bond. So actually between A and A atom we have how many electrons? 2 electrons we have. While falling sunlight on it, sunlight means you are supplying energy. Supplying energy means bond will be breakdown. Okay, that breaking should be going equally. Equally means what? One electron comes to one bonded atom and one more electron goes to another bonded atom. After breaking, what we are getting? 2 identical particles we are getting. Those only we are calling as a free radicals. Free radicals means is a neutral species with single electrons. They are highly dangerous. Why? They are having unpaired electron. That's why they always want to becoming settled or stabilized by involving in the chemical reaction. That's why free radicals or highly energetic particle means highly reactive. They always try to attain the stability. Now comes to concept to us now. So can you give the one example for alkane? Methane. It will be involving in the reaction with the Cl2 in presence of sunlight. I am giving a different chemical reactions, means different products I am writing it carefully. First of all, only one hydrogen is replaced with one chlorine. We are getting which product? CH3Cl plus HCl. Is it? No, 2 moles of this one will be involving in the reaction with this one. Then what happening? 2 hydrogen atom is replacing. Then what we are getting? CH2, Cl2. Again we are getting 2 more HCl we are getting. No, we can get one more possible product is nothing but CHCl3 plus 3HCl we are getting. What is the maximum capacity? CCl4 plus 4HCl we are getting. Anyway, did you observe this one? Monohaloalkane, dihaloalkane, trihaloalkane, tetra. These we are commonly calling as polyhaloalkanes. More than 2 halogen atoms will be there, they are calling as polyhaloalkanes. Anyway, these all are under terms. Alkyl halide. Just for understanding, I will give you one explanation. For example, CH4 is there. It is involving in the reaction with Cl2. Sir, how you are getting CH3, Cl and HCl? So we are getting which particle? CH3Cl plus HCl. I am explaining according to free radical mechanism. First of all, first step, chain initiation. Cl and Cl is there, Cl2. So while falling sunlight, what happens? Bond will be breakdown through homoerotic cleavage. Homoerotic means what? The electron distribution going through particle will be equal. Then we are getting which one? 2 Cl radicals we are getting. After that, what happened in second step? CH4 is there. For my convenience, I am writing like CH3 and H. Any problem? No. Here also what happening? There is no much electron negativity difference. This is 2.1, this is 2.5. Very close relation, almost equal characteristics. Then here also bond will be breakdown. Then we are getting equal distribution of electron. We are getting. Then we are getting which one? CH3 radical plus H radical over. One CH3 radical, one chlorine radical. What we are getting? One CH3 and one chlorine radical is becoming like CH3Cl. Again, one more chlorine radical and one H radical. Together we are getting which one? HCl. One methyl radical, one chlorine radical. Methyl chlorine. One hydrogen radical and chlorine radical. HCl. You can do same thing with two hydrogen atom. Then to substitute, the like that will be going on. This is not a big issue for us. So whenever alkane will be reacted with halogen in terms of sunlight, you are getting alkaline. What is important for competitor? For example, this is the first one. Second one I am giving very important. You have to see carefully. Sometimes you ask in competitive examination. You take CH3, ethane, undergoing halogenation in presence of sunlight. How many isomers we are getting? The substitution may take place here and may take place here. Anyway, we are getting one product. That is nothing but 1-chloroethane. Yes or no? Means we are getting CH3, CH2, Cl. Very important concept. I am giving one more example for you. If you take CH3, CH2, CH3, it is involving in the halogenation. So then, how many types of alkyl halides we are getting? Mixer we are getting. Anybody can expect? Give the numbering 1, 2, 3. Substitution may take place at first position or second position. Again, third position is equals to first position. Are you getting or not? Just I will give you an idea for you. First of all, we are getting which one? First position substitution. CH3, CH2, CH2, Cl. What is the name? 1-chloropropane. Okay. Second position substitution. CH3, CHCl and CH3. 2-chloropropane or isopropyl chloride. Secondary alkyl halide. And also I will do third position. Do it. But it is equals to first one. Why? Because CH2Cl and CH2CH3 both are equal. Why? Because 1-chloropropane. If you can do at the last also 1-chloropropane. According to least number rule. That's why how many isomers we are getting? One isomer and another isomer. So if you take the propane under halogenation, we are getting two isomers. Isomers means what? Same molecular formula, same molecular mass, but due to some changes, its properties will be changing. Is it easy for separation? No. So that's why we are telling separation of isomers are difficult. That's why we are not using this method for preparation of alkyl halides. Why? Because under this reaction we are getting isomers mixture we are getting. Later if you want to separate them, it is not that much easy because they are very close in properties. Just I will give you some other things from competitive point of view. You see carefully. For example, CH3, CH2, CH2, CH3. Undergoing a halogenation, you may get how many products? Two isomers we are getting. So give the numbering 1, 2, 3, 4. 1 is equals to 4 and 2 is equals to 3. Substitution. Then first position substitution means what we are getting? CH3, CH2, 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 Cl. 1-chlorobutane. No, I want to go second. Possibility is there. Then we are getting CH3, CH2, CH, Cl and CH3. Is there any chance to get third and fourth? So third means is nothing but which one? CH2 CH3 is nothing but if you take okay, again what happening when you are doing substitution here, it is nothing but 2 chloro. You are doing substitution here, again is becoming 1 chloro. That's why you are getting 2 isomers. That's why separation will be very difficult. Okay, one important question I am asking, if you take pentane, how many isomers we are getting? Just you check it once. CH3, CH2, 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 CH3. This is important about competitive application part is important. Now we are doing reaction with Cl2 under sunlight presence. How many isomers we are getting of alkyl halides? 1, 2, 3, 4, 5. Do substitution at first carbon first. What are you getting? CH3, CH2, 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 Cl. First one plus. What do you get in second position? CH3, CH2, CH2, CH, Cl and CH3. Is it? Now third position is nothing but CH3, CH2, CHCl and CH2, CH3. And also I will do fourth position. Fourth position means is nothing but here nothing but 2 chloro. If you are doing fifth position, it is nothing but equal to. If you are giving substitution here means they will have to stop the numbering. No, automatically it is becoming 1 chloro-pentane. That's why under pentane we are getting how many isomers we are getting? 3 isomers. There is no clarity. If you want to separate them also very difficult because they are having very close in properties. I am asking one more final question under this one. Nothing but neopentane. Neopentane I am giving. Yes. Okay, if you take this alkane undergoing halogenation, we are getting how many possible isomers? Only one we are getting. Why? Because wherever you can do substitution here or here or here or here, we are getting same name. That's why we are getting only one isomer. What is that one? CH3, C, CH3, CH3, CH2, Cl. What is the name? 1, 2, 3. Name is nothing but 1 chloro. Yes, 2 comma 2 dimethyl. No, 2 comma 2 dimethyl. What is this one? Propane. Dimethyl propane. And also I will do below substitution to it. Then we have to start numbering one way. Then we are getting anyway we are getting the same name wherever you do substitution. That's why we are getting only one isomer. We are getting all of it here. Yes. Yes. Preparation we can see from alkenes. From alkenes. See very carefully, understand carefully, practice letter carefully. It's not a big thing, but understanding is very important. Okay, from alkenes. We know we learn from alcohols and alkenes. Now we are going under alkenes. See, under alkenes, what are the things? For example, here I am telling if you take any alkene, will be treated with halogens. It will be treated with halogens in presence of one of the organic liquid is nothing but CCl4. What is the name of CCl4? Carbon tetrachloride. We are getting which one? Haloalkanes we are getting or alkyl halides we are getting. Better write down alkyl halides. Alkyl halides. It is having some importance. Why? Because you can come to understand after finishing this one. What is this one? Alkenes will be treated with halogens in presence of CCl4. We are getting alkyl halide. That too, what type of alkyl halide we are getting means we can go depth. We are getting vicinal dihalides. We are getting vicinal dihalides. What is the meaning of vicinal dihalides? Halogens will be lying on adjacent carbon atoms. Yes, you can see that word. You see carefully. So alkenes means what? For example, CH2 double bond CH2 at Alkene. Is it alkene? Yes. Double bond compound is there. Halogen means, for example, I am adding Cl2 in presence of carbon tetrachloride. Why? Because to dissolve chlorine, it is also non-polar. It is also non-polar, easily dissolving and giving atoms undergoing attack. That purpose we are using that one. Okay. Now what happened? Is it participating in the addition or substitution now? Yes, you have to go to one more concept here. Addition reactions. Addition reactions is possible under unsaturated compounds. Unsaturated compound means what? May the compound containing double bonds or triple bonds. What happening addition is pi bond breaking, easily breaking. Why? Because weak bond. Pi bond breaking, add. Pi bond breaking, add. No, we have one more type of reactions, substitutional reactions. Substitution means what? Replacement. Okay, means it is only possible in case of saturated compounds. Saturated compound is especially alkanes. For example, you have methane, you have. Okay, na? Is there any chance for addition? No. Why? All are sigma bond, strong bond, but we can do replacement. So, for example, it is treated with X. What happening? X is replaced with, sorry, hydrogen is replaced with X. Then we are getting which one? C, H, and we are getting X. These are calling as a replacement. If suppose chemistry sir is not there, then physics sir will come. This is calling as a replacement. There is no addition. Okay, but addition is possible when unsaturated compound. That's why we have to understand very simple. Additional reactions will be possible under alkenes and alkanes. Substitutional reactions possible in only alkanes. Now, it is going additional or substitutional? Additional. How? Anybody? Additional reaction. Addition is what? Breaking of pi bond, not sigma bond. Why? Because pi bond is a weak bond. After breaking, it's becoming unbalanced. To balance that bond, one chlorine will come here, one chlorine will come here. Then we are getting which bonds? CH2 single bond, CH2 on this one chlorine will come, on this one chlorine will come. Thus calling as vicinal dihalide. If you want to call this one, that is nothing but which one? Alkyne dihalide, ethylene dihalide, or ethylene dichloride. Already we learned in the introduction classes. Okay, now I will give you one important thing. It is the test for unsaturation. Is coming in bio questions in practical examination. Test for unsaturation. Saturation. Test for unsaturation is you take for example one unsaturated organic compound. To that you are adding bromine liquid. You are adding bromine liquid means actually it is in golden yellow color. Golden yellow color liquid it is. Yes, you have a test tube. In the test tube, one organic compound is there. You don't know whether it is an alkene, and you want to come to know whether saturated or unsaturated. Then what happening? Actually, this compound is colorless now. Now what you are adding? Golden yellow color bromine liquid you are adding. After that, what happening? If color is remains or color is disappears. If suppose color is disappears, why color is disappears? It is participating in the chemical reaction with this one through additional reaction. Then what we are getting? CH2Br and CH2Br we are getting. Finally we are getting colorless liquid we are getting. If color is disappears, why color is disappears? Bromine is involved in the reaction. Why bromine is involved in the reaction? Here unsaturation is there. If like that, after mixing you are getting colorless liquid, we can feel that compound is nothing but unsaturated. May the compound containing double bonds or triple bonds. Then no, you taken one organic compound, to that you are adding golden yellow color bromine you are adding. Still golden yellow color is remains. Means what? No reaction. No reaction is what? Here no double bond. No double bond which is calling as a saturated. That's a test for unsaturation. Okay, whatever organic compound if you can take, to that you are adding golden yellow color bromine liquid. If color is disappears, means chemical reaction is happening. Chemical reaction is happening means their unsaturation will be there, made double bond or triple bond. No, after adding golden yellow color liquid, still it is remaining, means no reaction. Why no reaction? The taking compound is saturated. Saturated means alkane. This part is one of the tests for unsaturation. This process is going like this. Now we are discussing one more thing and very important. You learned under the alkenes hydrocarbons concept. You take for example from alkenes only. You take alkene, that is nothing but symmetrical alkene you can take. Symmetrical alkene. Symmetrical alkenes, that is heading, if you want to keep it, it is nothing but hydrohalogenation. Hydrohalogenation. Yes, nice concept. I have to understand very carefully. Just halogenation means introducing of halogen. Hydrohalogenation means both hydrogen and halogen are introducing. Is nothing but Introducing of HX particle into a given organic compound is called as hydrohalogenation. Okay, first of all I am taking alkenes or otherwise symmetrical alkenes you are taking. You take commonly alkenes. Alkenes will be treated with hydrogen halide. Then we are getting alkyl halides. Alkyl halides we are getting. Okay, here problem is coming. First of all, you take a symmetrical alkene. Simple thing, symmetrical alkene. We are taking a symmetrical alkene. We are taking symmetrical alkene. To that I am adding, for example, HCl I am adding. What is the meaning of symmetrical? Symmetrical means, you see carefully here, with respect to double bond, both sides same number of carbon is there. Left side one carbon, right side one carbon. No, you take here two carbons, here also two carbons. Means with respect to double bond we are getting same number of carbon atom on both sides is calling as a symmetrical. Unsymmetrical means what? C double bond, single bond, C dies. This is calling as symmetrical alkene. It is calling as unsymmetrical alkene. Unsymmetrical means what? With respect to double bond, unequal number of carbons on both sides. Left side two carbons is there, but right side one carbon is there. So calling as unsymmetrical. Now first of all we are discussing about the symmetrical alkene. Okay, I am taking for example CH2 double bond CH2. To this what you are adding now? Hydrogen halide you are adding, like HCl or HB or HI you are adding. So then we are getting which one? Alkyl halides we are getting. Alkyl halides. Can we get how you are getting? Addition no. Why? Because unsaturation. Breaking off pi bond. Okay, what happening? Hydrogen may attack here or hydrogen attack here, automatically chlorine attack here. Then what is becoming? CH2 is becoming like CH3 and CH2C. And also I will do it hydrogen attack here, do it CH3, CH2Cl. You are getting same product. That is nothing but 1-chloroethane. Or chloroethane we are getting. Are you getting now? So under symmetrical alkene, while addition of hydrogen halide, we are getting only one type of the product wherever you add hydrogen or chlorine. But problem is here is nothing but unsymmetrical alkenes. You see carefully, problem is here nothing but unsymmetrical alkene. Unsymmetrical alkenes, reaction with hydrogen halide, we have to follow two rules. Anybody? We are getting two rules. One is Markovnikov's rule. Markovnikov's rule. Another one is anti-Markovnikov's rule. Anti-Markovnikov's rule. Symmetrical no problem, wherever you add you are getting same product, but under unsymmetrical alkenes while adding hydrogen halide you have to follow Markovnikov and anti-Markovnikov according to given conditions. First of all, we are discussing about the Markovnikov's rule. Markovnikov's rule. You see carefully now what is the Markovnikov rules under this one. You take one unsymmetrical alkene, best example CH3, CH double bond CH2. Is appearing very clearly. With respect to double bond, left side two carbons is there, right side only one carbon is there. With respect to double bond, it is unsymmetrical. That's why it's calling it as an unsymmetrical alkene. To that, I am adding hydrogen chloride. The reaction going through Markovnikov rule. What is a Markovnikov rule? Always, yes, you have to get it. Always negative particle is added at a lesser number of hydrogens having or hydrogen atoms having double bond carbon atom. Double bonded carbon atom. Yes, you learned already in first year. Just once again you see. So whenever you are taking unsymmetrical alkene, you are adding hydrogen iodide. The process is going according to Markovnikov rule. What Markovnikov rule is telling? Always negative particle should be added to the lesser number of hydrogen atoms having double bond component. Means you see carefully here, double bond carbon is this one and this one. This double bond carbon having how many hydrogens? 1. This double bond carbon having how many hydrogen atoms? 2 atoms. Okay, but from here we are getting H plus and Cl minus. Yes, Cl minus will be adding here. Lesser number of hydrogen atoms having double bond carbon atom, that's why Cl minus will be attacking here, rule for that one, and H plus will be attacking here. Then what is the product? Yes, very good. Yes, tell me. CH3, CH, Cl, attacking no, addition no, bond breaking. Which bond? High bond. After that we are getting which one? CH. It's a major product. Are you getting? Yes, I want to give the explanation for this one. Sir, why happening like this? What is the secret behind it? It's good means you have to follow like that. No, what happening there? First of all, you see carefully. CH3, CH, double bond, CH2. Okay, now what happening? Two possibilities will be there to break the bond. This pi bond may shifting like this. First case, what we are getting? CH3, CH, shifting that side, no, we are getting here plus. And here we are getting minus. So this minus is attached with which particle? H plus particle first. So then what we are getting? H plus particle is adding here. Then we are getting which one? CH3, CH plus and CH3. And no sir, why only like that? I will shift left side, shift it. If you are shifting like this, what happening? CH3, CH minus and CH2 plus. Two possibilities will be there, but which is preferential we are studying. Okay, why shifting like this?